Okay, here's further guidance on problem 1-73 from lesson 1.2.3. The question is saying that Evan has graphed this 0.57, wants to reflect it over this line, and predicts that it's going to land at 2,2. How can we know this without graphing? The first thing I want to go back to is the first problem in this lesson, which was just talking about these two triangles being reflected. And what I want to point out is that from this point R to this point R, we are creating a line that is perpendicular to the line of reflection. And so when I start looking at the slopes of these lines to kind of prove that it is perpendicular, we see that we go we go over 1, up 2. And so that is a slope of 2 over 1. When we look at the slope of the line that's connecting these 2 points, we can see that the slope is down 1 over 2, which is a slope of -1/2. Since these two slopes are opposite reciprocals of each other, I know that these two lines, the line of reflection and the line that connects the points, I know that those two lines are perpendicular. And to address the problem that we were going to get to, this is what we're going to use. We're going to use the idea that once a shape has been reflected, from point to point should always be you should always be able to use the opposite reciprocal slope of the line of reflection to travel from the original point to the new point. Again, you should always be able to use the opposite reciprocal slope of your line of reflection to travel from your original point to your new point. So when we look at this problem, we have our original point of 5-7. The opposite reciprocal slope of our line, well, our original slope is -2/5. That means the opposite reciprocal is going to be a positive 5 over 2, which means we have a rise of 5 and a run of 2. So up 5 to the right 2. Okay? Now, say I want to travel, I'm going to kind of work backwards here because that's positive. So if I'm at this point 2, 2. If I go up 5 from 2, if I add 5 to 2, traveling using that opposite reciprocal slope, my new point, if I travel up 5, is going to be something, comma, 7, because adding this 5 to this 2, we got 7. All right, now we need to go over 2 to the right, and we're starting at 2. So if I add 2 to that 2, I end up at 4-7. So using the correct math, using the correct slope, if I travel from the point he thinks it's going to land at, and I use the correct opposite reciprocal slope, I do not land at the point, his original point, meaning that that point is not a true reflection of the point he thinks it is. Okay, so without graphing, what I did was just use the opposite reciprocal slope to travel from one point to another to pretty much prove that one of these points must be off and it's not a true reflection. Because if it was a true reflection, it would have been 2, 2 and 4, 7.